So I know I've been harping on a lot recently about rockets the size of skyscrapers, and like the way we define skyscraper is like anything over 100 meters tall in terms of a building, we refer to as a skyscraper. So like Assassin 5, for instance, 110 meters tall. It's about the size of a 36-story building, a huge rocket. But you know what I mean, right? Like the size of rockets that we build, like edging into skyscraper territory. Just like I'm not like you see a 36-story building, thinking is it a skyscraper per se? You might think like, well, it's just a tall building. I don't mean that. I mean like we're gonna build rockets the size of Number One Canary Wharf, the size of the Gherkin, and maybe even if we need a machine as big as the Empire State Building one day, we can build them. We definitely can. Like, definitely. I'm pretty certain we can. They've just been building them out of aluminium. Why out of aluminium? Because it's light, but also because it's cheap. And I actually don't think I'm kidding about that one. It's like, oh, you get people like say, oh, it's because it's ductile, it's got like great cryogenic properties and so on and so forth. Like, yeah, but no one thought to build a frame out of fiberglass or carbon fibre, did they? Again, it's carbon fibre ductile. I mean, well, we build yachts out of carbon fibre. We make parts of aircraft out of carbon fibre, don't we? So, like, I think, like, your F-22 Raptors and your F-35s and so on, they're being built out of carbon fibre and composite materials and things like this. And yeah, they're very, very flexible. And they're pulling like 4 or 5 Gs at Mach 1.4 or whatever it is. I don't know, like weird term. They turn like when they're going out of course. Anywho, yeah, it's possible, definitely. Like, it's just because we haven't thought to do this. I don't think. Like, yeah, what they're doing with the SLS, like they were pushing the limits of what they could do with aluminium alone. You know, like what's the building material? Like, this is like I'm afraid to say like how ordinary science or like, excuse me, like yeah, I know like engineering is not science. Okay, I know it's like a cross between an art. Well, it's both art and science. It's obviously underpinned by scientific principles, you know, but and it's clearly a creative discipline. It's about making things, but yeah, it's no one's thought to do it. Like no one's thought to do it with skyscrapers either. That's why I think I know this. I mean, this is like kind of ethos in engineering. You know, it's monocultural building. You know, we need hybrid structures. You know, we need something like a skyscraper with the rigidity of carbon steel. You know, with that big Young's modulus of about 180 to 190 to 200 something GPa gigapascals. You know, because you can't build frame out for a skyscraper out of carbon fibre because it's too flexible. You get this going on at the top, right? So like build one frame out of carbon steel, but buttress it with carbon fibre, so you can take advantage of the 3,500 megapascals of tensile strength rather in carbon fibre. You build that buttress for the frame, then like you can have all that weight bearing down on it, and it's fine. It's not going down on the steel. Well, it doesn't matter since the steel is just, in essence, strapped to the carbon fibre, or the carbon fibre is strapped to the steel. In any case, the material with the greater load bearing capacity, so its tensile strength is going to take it and build higher and higher. The rigidity comes from the steel, so you get the best of both worlds. With probably quite a few more nuances, I have to say, but like it's not been attempted. No one's done this. I think they would have done if you could do this. You could build like a mile-high skyscraper. Jesus, I mean, like from back of the envelope calculations, but you know, back of the envelope calculations, which must be taken with a pinch of salt, is yeah, probably a hell of a lot more subtlety to it than that. Yeah, by back of the envelope calculations, I've sort of deduced that you may be able to build using hybrid, structures, both carbon fibre and carbon steel in your structure for a skyscraper. It was at 10,000 feet. Like a skyscraper at the cruising altitude of airliners. I don't know why you need to build something like that high, but like how you'd get to the offices. But like the limits of what we can build are astounding, really. And this is, I think, kind of a rebellion against naysaying. I like to think that. Oh, no, we can't do that. Stop. You don't know. You actually don't. So that's it.